Good morning. This hearing will come to order. Without objection, the chair is authorized to declare recess at any time. Before I deliver my opening remarks, I wanted to note that today the committee is meeting both in person and virtually, both members and witnesses. And I want to announce a couple of reminders to the members about the conduct of this hearing. First, members and staff who are attending in person may choose to be masked, but it is not a requirement. However, any individuals with symptoms, a positive test, or exposure to someone with COVID-19 should wear a mask while present. Members who are attending virtually should keep their video feed on as long as they are present in the hearing. Members are responsible for their own microphones. And also please keep your microphones muted unless you're speaking. Finally, if members have any documents they wish to submit for the record, please email them to the committee clerk whose email address was circulated prior to the hearing. Good morning and welcome to today's hearing, looking back to predict the future of the next generation of weather satellites. I want to welcome our witnesses. We're pleased to have you here, both in person and virtually. Today, the Subcommittees on Environment and Space and Aeronautics are meeting jointly. I want to thank Chair Sherrill for her collaboration on this hearing. The importance of advanced, reliable weather prediction and understanding of long-term climate trends can't be understated. Devastating winds, storm surges, and flooding in Alaska and Puerto Rico are just recent examples. While weather continues to present serious risks to life and property, we've come a long way from 1900 when a hurricane with 135-mile-per-hour winds decimated Galveston, Texas, and wiped out 8,000 lives and an estimated 3,600 buildings. Our nation's weather satellites and instruments are the workhorses that provide imagery and data to feed weather forecast models and predictive tools. These critical satellite capabilities support the government's core weather services, global users, as well as a thriving commercial weather industry. Today, advanced technologies increase scientific understanding of the Earth system and a burgeoning commercial space industry, providing new options and opportunities for our next generation of operational weather systems. We need to start by looking back to predict the future, and that story begins with NASA. In the early stages of our space program, NASA developed and launched in 1960 the world's first weather satellite, the Television Infrared Observation Satellite, TIROS-1, equipped with 2 television cameras and 2 video recorders that proved the value of space-based weather operations. A year later, President John F. Kennedy, in a historic May 1961 speech to a joint session of Congress, included a request for appropriations that will, quote, will help give us at the earliest possible time a satellite system for worldwide weather observation. Follow-on to TIROS satellites led to NASA's Nimbus series, as NASA worked first with NOAA's precursor and then NOAA to establish a weather satellite system. NASA also developed the first geostationary weather satellite, followed by the first operational geostationary operational environmental satellite, GOES, in 1975. And today, through a reimbursable arrangement with NOAA, NASA leverages its decades of experience to manage NOAA's satellite and instrument development, acquisition and contracting, and launch services. And once NASA checks out the satellite's on-orbit performance, it hands responsibility to NOAA for operational services. The benefits of NASA's contributions, however, don't end there. NASA and NOAA can transition instruments initially designed for NASA's cutting-edge space-based earth science research into NOAA's operational weather systems. The Moderate Resolution Imaging Spectrometer, MODIS, on NASA's Earth Science Terra and Aqua satellites led to the development of the Visible Infrared Imaging Radiometer Suite, VIRS, a key instrument on NOAA's current Joint Polar Satellite System series. And NASA's planned Earth Science Tropics mission, to involve a small satellite constellation, could, if successful, provide options for future weather satellite missions and architectures. NOAA's and NASA's collaboration is long and strong, though the partnership has had its share of changes over time. The challenges and eventual dissolution of the prior tri-agency, NOAA, NASA, and DoD, NPOESS Weather Satellite Program, led to NASA's establishment of the Joint Agency Satellite Division within the Science Mission Directorate. The division provides a dedicated effort to manage NASA's work for NOAA. It's clear both NOAA and NASA have learned a lot. Their decades-long relationship has matured to the point where NOAA and NASA jointly chair program management councils. We need to examine the lessons of this partnership, especially as the federal government considers equally challenging and important interagency efforts, including a space situational awareness, an area in which Space and Aeronautics Subcommittee are actively working together. Because reducing miscommunication and facilitating information flow are essential if we are to develop successful systems, such as weather satellites, while minimizing cost, schedule, and management challenges. For example, challenges with the GOES are program's key instrument, the Advanced Baseline Imager on the currently operating GOES 17 satellite, led to significant redesign of the instrument for the follow-on GOES-T satellite, which launched 18 months later than planned. Ensuring that lessons learned from previous mistakes are incorporated into future programs is essential to successfully executing NOAA's critical weather forecasting program. So I look forward to hearing from our witnesses on how NOAA and NASA's partnership and decades of experience and lessons will lead and advance our nation's next generation of weather satellite systems. So let me now recognize my friend, the Space and Aeronautics Subcommittee Ranking Member, Dr. Brian Babin, for an opening statement.
Thank you, Mr. Chairman. Thank you for holding today's hearing as well, and looking forward to hearing from our witnesses. One of this committee's top priorities in recent years has been improving the accuracy of weather forecasting in the United States. NOAA's short and long-term weather forecasts utilize data from several sources, including a fleet of satellites orbiting above. These satellites in polar and geostationary orbit provide needed observations of the Earth system that are vital in the development of our weather forecasts, as well as monitoring and preparing for extreme weather events. NOAA partners with NASA for the acquisition and the development of these satellites. NOAA establishes its requirements, and NASA issues contracts to develop these satellites within budget and ensure that they meet the technical specifications laid out by NOAA. NASA is responsible for the launch of these satellites and then turns over responsibility of these operations to NOAA. And though NOAA still has one more geostationary satellite to launch in 2024, the agency has laid out its initial plans for the next generation of geostationary satellites, which will be known as the Geostationary Extended Observation System, or more commonly known as GeoXO. At the same time, NOAA is continuing the deployment of its polar satellites through the Joint Polar Satellite System, with the next satellite, JPSS-2, scheduled for launch in November. And though these systems are currently working well, that was not always the case. A previous system of polar orbiting weather satellites to be developed in partnership with the Department of Defense, known as NPOS, was canceled due to cost overruns, technical challenges, and schedule delays. Additionally, the recently launched GOES-T satellite was delayed by more than 18 months because of a needed redesign of its Advanced Baseline Imager, or ABI, due to technical issues experienced by its predecessor, GOES-S. Both GAO and the Department of Commerce's Inspector General have engaged in extensive reviews of NOAA's development process for its fleet of weather satellites and have offered a number of recommendations for how best to improve that process. Today's hearing should focus on how well NOAA has implemented these recommendations in the development of the current fleet of satellites, as well as what lessons still must be applied to the next generation of weather satellites. This committee has a responsibility to ensure that taxpayer dollars are spent in the most responsible manner possible, and we are getting the highest value for these satellites. As we consider how best to maximize the use of taxpayer dollars, we must continue to explore ways the federal government can partner with the private sector to provide critical data. We have seen tremendous growth in the capabilities of the commercial satellite industry in recent years. The Weather Act, sponsored by Ranking Member Lucas, and the Pro-SWIFT Act both contain pilot programs that allowed NOAA to purchase data from commercial sources. We have seen the commercial sector willing and able to provide data to NOAA. In fact, NOAA recently announced a second request for radio occultation data from commercial weather satellites. Additionally, the agency announced that 3 companies have received contracts to provide space weather data to the agency. As we look ahead to the next generation of NOAA's weather satellites, we should consider how we can continue to leverage the innovation and the resources of the private sector as we work to provide the best weather forecast possible. I want to thank our panel of witnesses for appearing before us today, and I look forward to a very productive discussion on this very important topic. And so with that, I'll yield back, Mr. Chairman.
Thank you, Doctor.
Yes, sir.
The chair now recognizes the Environment Subcommittee Chairwoman, Mikey Sherrill, for an opening statement.
Well, thank you so much, Chairman Beyer, and thank you to our ranking member, Dr. Babin. It's wonderful to be here today, and to our witnesses, thank you for joining us, both in person and virtually. I'm looking forward to hearing about the successes and lessons learned from the current weather satellite programs, as well as learning more about what is to come with the next generation of satellites. The National Oceanic and Atmospheric Administration's weather satellite programs play a key role in its mission to share Earth observations and scientific data used by the public, private, and academic sectors. Access to this knowledge is critical to communities in becoming resilient, weather-ready. My district and many of my colleagues' districts have seen increasingly frequent and severe weather. Communities such as Little Falls, Woodland Park, and Denville in my district have faced repeated catastrophic and sometimes deadly flooding events, such as the high-intensity rainfall from remnants of Hurricane Ida. I'm interested in hearing from our witnesses today about how observations by these satellites and the next generation after them will give communities like those in New Jersey's 11th District accurate and up-to-date forecasting tools to predict and avoid life-threatening weather, especially extreme rainfall, and confront the ever-worsening effects of the climate crisis. At the national level, rainfall and flooding like that experienced in New Jersey and other extreme weather events can cause billions of dollars in losses to our communities. NOAA found that by July of this year, the U.S. had already experienced 9 weather and climate disasters that exceeded $1 billion each, and the year is not over yet. We are still in the midst of what is predicted to be an above-average Atlantic hurricane season, and just this past Sunday, Hurricane Fiona made landfall in Puerto Rico, knocking out power to the island and causing catastrophic flooding. That's why this hearing is so critical. So many aspects of our society and our economy depend on the environmental, weather, and climate information collected from these satellites. Any potential satellite malfunction or launch delay could cause data gaps that would be devastating to national security, the U.S. economy, and most importantly, public safety. It has been several years since this committee has done extensive oversight over our nation's operational weather satellite programs. Today, we will hear about the successful partnership between NOAA and NASA to develop, launch, and operate the current generation of geostationary and polar orbiting weather satellites. In fact, earlier this year, we celebrated the successful launch of the 3rd satellite in the GOES-R series, and we look forward to what we hope is another successful launch of the JPSS-2 satellite later this year. The credit for these recent successes is largely due to our esteemed NOAA and NASA witnesses today and the teams that support their efforts. However, this partnership has not been without its issues, as we've heard. Both the Joint Polar Satellite System and Geostationary Operational Environmental Satellite programs initially faced ballooning costs and extended delays. Since then, NOAA and NASA have successfully turned around these programs. Despite some challenges, including instrument malfunctions on orbit, the agencies have worked to ensure no disruption in observations and that the same mistakes are not repeated. Continued planning, testing, and adjustments are required to minimize the risk of any potential loss of observational data. I hope to hear about the current contingency plans in case any potential malfunctions or mishaps occur, and how NOAA and NASA will work together to address any issues. As the projected end-of-service dates for both the GOES-R and JPSS series are expected at the end of the next decade, it's important for NOAA to be developing the capabilities of the next generation of satellites with the help of NASA's expertise. NOAA is taking into consideration new technologies and increasing user needs through input from a variety of stakeholders while establishing the future satellite architecture in a timely and cost-effective way. With all these considerations and lessons learned from the current weather satellites, I look forward to hearing from NOAA and NASA about their progress in the next generation of weather satellites. The time is right for a discussion on GeoXO and the future of low Earth orbit and space weather satellites. The importance of these satellites providing uninterrupted environmental and weather observations at a time when climate change is causing more severe and frequent extreme weather events cannot be stressed enough. The Department of Commerce's Office of Inspector General's continuous oversight of the satellite programs provides Congress and the public with consistent updates on possible risks these programs may face. I look forward to hearing the OIG's findings of a recent audit on NOAA's progress of the next generation satellites, as well as any recommendations OIG may have in improving this progress. Again, I thank you to our witnesses for being here today. My colleagues and I are committed to supporting the continued success of the nation's operational weather satellites. And with that, I yield back. Thank you, Mr. Chair.
Thank you, Chairwoman Sherrill, very much. Now, the Chair recognizes the Environment Subcommittee Ranking Member, Congresswoman Stephanie Bice, for an opening statement.
Thank you, Chairman Beyer and Chairwoman Sherrill. And thank you to our witnesses for taking the time to share your expertise with us this morning. When you drive across the state of Oklahoma, you can easily spot many signs of the traditional weather enterprise. You'll see weather stations and their Doppler radars and transmitting towers. You'll see mesonet stations on public and private land that make up our best-in-class state system. And if you can make it to Norman, Oklahoma, you'll see the National Weather Center, a premier hub for federal, state, and academic research related to weather modeling and prediction. But all of this is just half of our capabilities. What you can't see are the highly technical instruments orbiting above us in space. To truly understand and monitor the full range of global and national weather patterns, NOAA, NASA, and the National Weather Service collaborate on a fleet of satellites that circle the Earth and collect vast amounts of data critical to weather modeling and forecasting. Currently, NOAA owns or operates a total of 16 satellites, 10 of which they own and operate themselves. The other 6 are partnerships in which NOAA is critical to the operations. Many of them are the result of recent efforts and congressional support. In fact, it was just in March of this year that NOAA launched its most recent and most sophisticated satellite, known as GOES-18. The GOES program has faced its fair share of challenges, ranging from equipment failures to COVID delays. But I look forward to the launch of the final satellites in this series, GOES-U, in 2024. I'm also eager to discuss the lessons learned as we transition to the next generation of satellite systems, GeoXO. At the same time, it is important that we remember that the design and launch of satellites are just 2 pieces of the puzzle. In order to truly see the maximum benefits of these efforts, we must ensure that the data is useful to the weather community and that we have adequate ground systems to get the information obtained from space to them. An important part of this will be the development and use of high-performance computing by the weather enterprise. More computing power and better models will allow meteorologists to input large amounts of data, run weather models more times for accuracy, and produce a higher resolution forecast, ultimately saving lives and property. Although there is room for improvement and increased support, NOAA should not be alone in this effort. The commercial weather industry has seen tremendous growth over the last decade and has shown the value their partnerships can add to federal agencies' existing efforts. Private companies and research institutions have both computing resources and satellite data, both of which NOAA can acquire for use for a fraction of the cost it would take for them to build it out. The Commercial Weather Data Program at NOAA has proved these partnerships can be successful and benefits all parties involved. Additionally, researchers at universities can lead the development of next-generation instruments that can either be added to the commercial satellites or launch on their own dedicated payload. These are the type of cost-effective solutions we should encourage and support to supplement federal observation efforts. Again, I want to thank the witnesses for being with us this morning, and I look forward to your testimony. Mr. Chairman, I yield back the balance of my time.
Thank you, Congresswoman Bice. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. At this time, I'd like to introduce our witnesses. Our first witness today is Dr. Stephen Volz. He's the Assistant Administrator of the National Environmental Satellite Data and Information Services at NOAA. Dr. Volz has 35 years of professional experience in aerospace. He's a leader in the international Earth observation community, serving as NOAA's principal both to the Committee on Earth Observation Satellites, CEOS, and to the Coordinating Group of Meteorological Satellites. Dr. Volz is the principal U.S. representative to the International Group on Earth Observations, and he helps lead efforts to coordinate global satellite-based observations among the international space agencies. He serves as the co-chair of the NOAA Observing Systems Council and is also a member of the NOAA Executive Council. Our next witness today is Mr. John Gagosian. Mr. Gagosian serves as director of the Joint Agency Satellite Division at NASA, which is responsible for the development of space systems supporting operational weather observation requirements of NOAA. In his role as director of JASD, he assesses program and project performance as well as risk. Prior to joining JASD, Mr. Gagosian represented NASA's Science Mission Director's Astrophysics Division Program Executive for the Exoplanet Exploration Program and the Nancy Grace Roman Space Telescope. Mr. Gagosian also previously served as the Program Executive for the Hubble Space Telescope, Stratospheric Observatory for Infrared Astronomy, and the Cosmic Origins Program. Our final witness is Mr. Frederick Meny. Am I saying that right? Okay, great. Mr. Meny is the Assistant Inspector General for Audit and Evaluation at the U.S. Department of Commerce. He leads the oversight efforts regarding intellectual property, IT security, cybersecurity, and satellite and weather systems. Mr. Meny has more than 35 years of federal government experience in leading, managing, and directing organization staff, budgets, and IT resources, as well as major systems acquisition and development programs. During his 25 years with the OIG, Mr. Meny has led numerous reviews that improved the 2020 and 2010 decennial censuses, department-wide acquisitions and grants, First Responder Networks Authority Management, USPTO's patents and trademarks, and NOAA's polar and geostationary satellites and weather systems development and operations. We are delighted to have all of you here. As you should know, you'll each have 5 minutes for your spoken testimony. Your written testimony can be much, much longer and will be included in the record for the hearing. When you've all completed your spoken testimony, we will begin with the grueling questions. Each member will have 5 minutes to question the panel. So we will start with Dr. Volz, who is here with us virtually. Dr. Volz, the floor is yours.
Thank you, sir. Good morning, Chairs Cheryl and Beyer, and ranking members Weiss and Babin, and all members of the committee. As I've been introduced as Dr. Volz, head of the NOAA's Environmental Satellite Data and Information Service. It's a real honor to be invited to speak to you, and it's a pleasure to talk to you about the successes we've had and about the importance of the information from our satellite observing system to address the challenges from climate change and severe storm events that we are experiencing. We need no greater or more compelling reminder of the importance of our mission than the terrible storms that have made landfall in Puerto Rico and Western Alaska in just the last few days. NOAA has a very unique mission to understand, predict, and support the health of our oceans and atmosphere. We save lives, protect property, and enhance the American economy by monitoring and forecasting weather, water, and the climate, informing our citizens every day. We deploy ships and planes, buoys, balloons, and drones, and satellites. Satellite data account for around 90% by volume of all the data used by NOAA's forecast models, and satellites are essential to develop and to extend essential planetary climate data records, which allow us to understand the changing planet. But we don't just use satellite data. In fact, NOAA devises plans for the nation's environmental satellite program, manages their construction and operates them, while NASA builds and launches them on our behalf. NASA is our longest standing and closest strategic partner in observing Earth from space. Our agency's missions are complementary. NASA and NOAA both conduct Earth and climate science research and model development. NASA develops new space technologies. NOAA exploits those and other technologies and delivers the observations and information that the nation needs. And that need is great and growing greater. Our experience with hurricane observations and research has taught us this lesson over the years, that better observations from satellites, geostationary and low Earth orbit, from aircraft and other systems, and better research and data assimilation all have led to improved forecasts and outcomes for communities in the paths of storms. Since Hurricane Andrew in 1992, we have reduced hurricane track accuracy error by 75% and intensity forecast error by 50% with these efforts. We will continue to face hurricanes stronger and more frequent than in the past, but we're also dealing with significantly more frequent and severe extreme events, including wildfires and flooding. We need to be able to forecast fire and flooding events, as well as derechos and ice storms, with the same level of confidence, not hours, but days in advance, to prepare emergency managers and communities to respond. To do this, we need better observations and better models. And NESDIS is working to deliver those improvements with our next generation satellite observing system, with better and more information, all leading to a better NOAA. Recently, we completed the NOAA architecture study to help define our next generation missions and integrate NOAA's assets with those of our international and commercial partners. We have demonstrated with our current programs the value of buying instruments and other essential program elements in bulk to reduce mission cost and risk, and the value of selectively using different contracting approaches. NOAA's geostationary satellites provide the only continuous near real-time observations of the Western Hemisphere, supporting severe weather and extreme events, watches, and warnings. Our next generation geostationary extended observations, or GeoXO mission, will continue and expand the current GOES-R series. GeoXO's first launch will be in 2032, followed by 5 more satellites with planned observations through 2055. One of GeoXO's advanced capabilities is a hyperspectral infrared sounder. This sounder instrument will provide significantly improved real-time vertically resolved observations of wind speed and direction. With these data, experts will be able to better track and monitor storms and to better predict the behavior of fire and smoke. NOAA's current fleet of low Earth orbit satellite, JPSS, provides continuous observations, and together with our partner satellites, are the backbone of the global weather forecasting models. NOAA's future LEO satellites will supplement and eventually replace our current JPSS satellites. They will provide more frequent and varied observations and better spatial and vertical resolution, improving modeling and driving higher resolution short and long-term weather forecasts. Our nation's current space weather system includes NOAA observations along with NASA and other research satellites. And with these, NOAA provides forecasts that help safeguard power grid infrastructure, civil aviation, and spacecraft and astronauts. Space Weather Next will maintain and extend those observations from multiple observing points to improve critical storm forecasts for current users and for the expanding commercial space industry. These observations are required and has been authorized through the PROSPEC. In conclusion, I'll state, we know our citizens need weather and environmental information to thrive in this changing world. NOAA and NESIS were not only ready to do this, we were created for this mission. And I thank you for your strong and continued support of NOAA's mission and its satellite program. And I'm happy to answer your questions. Thank you, sir. And back to you, Chairman.
Thank you, Dr. Volz, very much. We'll now hear from Mr. Gagosian.
Good morning, Chairs Beyer and Sherrill, Ranking Members Babin and Bice, members of the committee. My name is John Gagosian, and I'm the Director of the Joint Agency Satellite Division at NASA headquarters, a unique office charged with overseeing the development and launch of satellite systems to meet NOAA's research and operational mission requirements. Yes, you heard that correctly. We are charged at NASA with meeting NOAA's needs. But I want to emphasize the way our collaboration with NOAA on weather satellites has strengthened our larger partnership with our sister agency. I'll discuss the benefits that our cooperation offers to both agencies and share a bit of what we're looking forward to in the future. As the chairs and ranking members described so well, since the 1960s, NOAA and NASA have been strategic partners in research and operations, with NASA focused on answering emerging scientific questions and NOAA focused on using environmental information to safeguard the public and grow our economy. In this relationship, NOAA has long coordinated with NASA in the development of its satellites, taking advantage of NASA's unique expertise in developing and launching space systems. The two agencies have 3 integrated joint program offices at NASA's Goddard Space Flight Center in Maryland. NOAA provides overall program management requirements and budget, while NASA is responsible for the acquisition and development of mission systems through its rigorous flight program management processes. At Goddard, work is directed by interagency leadership teams and governed by joint agency management councils to ensure close collaboration in every step of project development. In this structure, NOAA maintains programmatic authority, and NASA exercises technical authority, using a tailored and formally documented process. Following launch, on-orbit checkout, and validation by NASA, NOAA takes over operation of its satellites. Together, we have developed the JPSS series, the GOES-R series, and the Discover Space Weather Monitor. We're looking toward the next generation of geostationary satellites, the GeoXO program, which will include the addition of ocean and atmospheric monitoring. We're also working toward a new architecture of low Earth orbit satellites, starting with QuickSounder, and the future of space weather monitoring with Space Weather Follow-On and Space Weather Next programs. Throughout this work, both NOAA and NASA can point to many successes that have come through collaboration. The state-of-the-art instruments that NOAA uses in its JPSS series have built upon NASA instruments first developed for the Earth Observing System in the 1990s. NASA has also been able to host its own research instruments on JPSS satellites, for example, to monitor ozone and to measure the energy reflected and emitted by the Earth. NASA missions like TEMPO, monitoring air pollution across America, and GLIMMER, measuring ocean color along our coasts, have led directly to capabilities planned for NOAA's GeoXO program. GeoXO will bring new capabilities to address emerging environmental challenges of the future in support of U.S. weather, ocean, and climate operations. NOAA's radiation monitors in geostationary orbit are critical sources of data for NASA's space weather research. They provide key measurements demonstrating that solar variability is driving space weather processes. These measurements are currently performed by the GOES-R series and will be transitioned to the Space Weather Next series in the future. Indeed, many of NOAA's operational assets are crucial for NASA's research, and our common data needs have led to joint work, advancing data assimilation and modeling. Together, NOAA and NASA are leveraging the best innovations across the space industry to reduce costs and improve the capabilities of future missions. Our work toward a network of small, low Earth orbit satellites can improve global coverage, reduce development timelines, and more quickly infuse new technologies. We've explored new acquisition strategies that rely on the private sector for mission operations and data transport, and have executed commercial data buys using licensing agreements that allow us to share the data with other government agencies. We have reduced the cost of access to space via secondary payloads, hosted payloads, and new launch vehicles. We also see the potential in cloud computing, artificial intelligence, and machine learning to enable research and improve data products. In summary, our two agencies' close collaboration has allowed each of us to accomplish far more than we could have achieved on our own, and has amplified the unique benefits that each of us bring to the nation. We thank you for your support of our joint operations. Thank you for inviting NASA to join this hearing today, and I'd be happy to take any questions.
Mr. Gagosian, thank you very much. And next we'll hear finally from Mr. Meny. The floor is yours, sir.
Thank you, Chairman Byer, Chairwoman Sherrill, Ranking Members Babin and Bice, and members of the subcommittees. Thank you for the opportunity to testify today. NOAA satellites are vital to the nation and its ability to collect weather and climate data for warnings and forecasts. As an Assistant Inspector General for the U.S. Department of Commerce, Office of Inspector General, my office has oversight responsibility of the NOAA satellite programs. We have conducted many audits of these programs that have made numerous recommendations to improve their efficiencies and effectiveness. The cooperation of both NOAA and NASA leadership and staff has facilitated our oversight, and I am very pleased to join my fellow witnesses today to discuss the next generation of weather satellites. My written testimony summarizes challenges pertinent to this hearing in our FY22 Top Management and Performance Challenges report, as well as results from 2 recent audits. This morning, I would like to offer 3 observations from that work. First, delivering fully capable satellite systems on orbit is a technical challenge that requires adherence to sound system engineering and mission assurance practices. However, the need to stay on schedule can sometimes lead NOAA to make risk-based decisions to deviate from those best practices. NOAA aggressively manages its launch schedules to mitigate potential data gaps. However, we have found that an overly schedule-driven approach can sometimes have negative performance effects when critical testing or other steps are modified to stay on schedule. In our latest audit of the GOES-R program, we found that NESDIS is planning launches of those satellites sooner than its policy requires. This results in more frequent launches and therefore higher costs over time. To justify this practice, we recommend that NESDIS conduct a cost-benefit analysis and update its governing policy accordingly. Our second observation is that NOAA policies and procedures need to be fully aligned to the needs of users of satellite data. User needs, well-defined and validated, become requirements that form the basis for systems architectures, design, integration, and verification. In our recent audit of NOAA's efforts to plan and implement its next generation of satellite systems, we found the need for improvement in NOAA's requirements management policy and practices. Most notably, NOAA's process for validating user observation requirements must be updated to meet the needs of next-generation satellite programs. The current defined process is not timely. NOAA also needs to ensure distinction between requirement threshold and objectives. These minimum and desired specifications create trade space that provide flexibilities in allocating resources. In addition, NOAA leadership must further distinguish the priorities of its user observation requirements. Satellite programs are often responsible for multiple mission-critical or priority one requirements. This can be a challenge for program managers who need to understand which requirements take precedence for risk-based decisions. My third and final observation is that NOAA satellite programs have had success avoiding potential data gaps, as well as applying lessons learned. The same program offices will also manage the acquisition and development of the next generation of satellites. To seek new efficiencies, NOAA should reassess many of their programmatic assumptions. We have often questioned such assumptions in our work, leading to recommendations and greater assurance that taxpayers' dollars are well spent. In conclusion, NOAA satellite programs are vital to the nation and require continued oversight. This hearing is an important effort in ensuring their success. Right now, my office has audits underway assessing space weather follow-on, GeoXO, polar weather satellites. As always, once our final reports are issued, I look forward to sharing our results with you and your staff. This concludes my statement. I would be happy to respond to any questions.
Mr. Meny, thank you very much. We'll now begin our round of questions, and I will begin. Dr. Volz, just listening to Mr. Meny, one of the things he said was that NOAA requires the program to work toward the earliest achievable launch dates for its satellite missions. And this is in order to minimize the risk of a satellite coverage gap. But that the aggressive planning dates can also increase pressure on schedules and lead to lots of bad decisions along the way. How do you respond to this pressure between the earliest possible launch and the need to do things right the first time?
So thank you for the question, sir. And I would say our primary focus when we look at the timeliness and the timeline for launching our missions is to assure the continuity of information to our users. Nothing's more important than making sure there's no gap in the information that goes into our weather forecasts or the emergency managers from our geostationary satellites. There will always be a tension between continuing testing versus meeting the launch date. And I would argue with the argument, we don't go to the earliest possible launch date. We're constantly looking at the health of our on-orbit constellation, and we're managing the system of observations we need. So, for example, for the GOES-R series, we have a policy which requires 2 satellites in orbit operating, goes east and goes west, and we have a flight spare in the middle of the sky between the two, so we have no more than a few hour delay. If we lose a satellite, we can turn the other one on. So we make sure we maintain that on-orbit readiness, and that's what drives our launch readiness for our birds that are being developed on the ground. So there will always be tension between the desire to do thorough testing and meet the launch dates, but we are driven by our need for continuity. And it's a constant balance, and the program managers know that. And we don't cut corners for testing. As you yourself stated up front, we delayed the launch of GOES 18 by a little over a year as we had to correct a problem we noticed on GOES 17. We did that knowing we had a healthy constellation, which allowed for that timeliness, that delay, in order to fix the instrument on the ground and yet not have a gap in our performance. We're constantly making these decisions all the time as we look at our satellite constellation.
Thank you,
Thank
Dr.
you.
Volz, very much. Mr. Gagosian, one of the things you wrote and talked about is that you're exploring alternative acquisition strategies, such as making the spacecraft prime contractor responsible for mission operations and data transport. This feeds in so much of the work that we're doing on the committee, especially the Space Subcommittee, on how the explosion of the commercial sector and how much can be meaningfully moved to the commercial sector without sacrificing quality and at a big cost. Can you expand on this a little bit? Do you see our weather satellites ultimately being managed by the commercial sector?
Thank you for the question, sir. So we're exploring a lot of different strategies for program management and acquisition, primarily now with the Quick Sounder project, which is the initial mission under the next generation low Earth orbit weather satellites. So we issued a request for information several months ago to the private sector, looking at ideas for how to execute, as I explained, a mission where the contractor is responsible for operations and data transport, basically delivering data to NOAA for processing and distribution. So we're looking at these techniques because we know that our commercial partners have best practices that they developed over the years for efficient operations. And we're going to take the lessons that we learned from Quick Sounder and apply those to planning future missions under the LEO program, which one of the visions for that program is a disaggregated constellation of smaller satellites, as I also referred to in my testimony, sir.
Thank you, Mr. Gagosian. Dr. Volz, one more question. The sum of much of the testimony is all about ever better data, better satellites, more sophisticated, better instruments and the like. Is it just about data, or how much is also about theory and modeling and going beyond being able to measure things more carefully to actually thinking differently about the data that you have?
And that's a great question to ask it that way. It's not about better data. It's about better information and better understanding. And that requires better data, but it also requires better understanding of what you're observing and the understanding of the Earth system. And that's a great example of where NASA and NOAA work together, where NASA does exploration missions to understand processes that drive different effects of the Earth. And NOAA is looking at how those processes affect our ability to forecast and predict phenomena that are of impact to our communities and our world. So it is there's a push-pull. The improved models identify what we understand and the need for greater resolution in the information. So as we go to a higher resolution model, we might need higher resolution data. And the better data of understanding of processes drives the modelers to look at a different way to analyze and predict the phenomena we're trying to forecast. So it requires both. It requires consistent and continuous improvement on both sides. And with the NOAA side, as we look at these new satellites, GeoXO, for example, we're actively working with the National Weather Service, Ocean Atmospheric Research Group, to understand what the models need and how the models need to improve and develop over the coming years. So they're ready to use the data when we provide it, and not just to not to leave the data untapped and unvalued as it gets delivered to them. So it takes both, and in coordination, and we're doing that very carefully as we look forward to these next generation satellites.
Great. Thank you very much. Let me now recognize the distinguished ranking member of the Space Subcommittee, Dr. Babin.
Thank you, Mr. Chairman. I appreciate it. As Dr. Volz noted, the scoping of the next generation satellite programs is underway, and definitive life cycle costs have not been finalized yet. It's important to note that life cycle costs can change in both good and bad ways. For example, the GOES program increased by 8% in 2020, while at the same time the Polar Follow-On program decreased by 9.7%. My question is for all three of you witnesses, and I think it's very simple. How do your agencies and programs ensure that the most accurate life cycle cost analysis is put in front of Congress so that we can know exactly what we're getting? Basically, how do we avoid starting what might seem like a minor endeavor, but watch it suddenly balloon into a major cost program that's far too far along to abandon?
So if I may take the answer first.
Yes, sir, Dr. Volz.
I think that's a great question, and I would say that we don't see any of our programs as minor, or any of the endeavors as minor. We treat them all as we're looking at building systems that will be operating for 20 to 30 years. So fully recognizing that it's not just the cost of a thing, a spacecraft or something, but it's the cost of the system and the impact of that system. So fully recognizing that and looking at the best of modeling techniques that we have for cost and schedule modeling that's been developed over many years. I spent 25 years with NASA developing and working on missions with different ways of doing cost estimating and programming. And we have a very rigorous combined NOAA-NASA approach to doing cost estimation and assessments, which are really accurate at determining the cost of space assets. And on the NOAA side, we have a long operational tail that we have to quantify as well. As we said, GeoXO is going to be operating into the early 2050s. So our models are varied, but actually look at those different pieces very accurately. And as we go through, for example, GeoXO coming up for a mission commitment in the coming months, we have numerous independent assessments as well as our grassroots bottoms-up assessments by the program team, which allow for a rigorous discussion of the pros and cons of different modeling approaches. And I think your own example of an 8% increase in one and a 9% decrease in the other reflected our ability to continuously revisit the life cycle cost, not as a emergency after we have a problem, but as a routine best practices. And we do that throughout the program, even after we start with an initial cost basis. Okay. And I'll turn it to colleagues, to John and to Fred for other comments.
Yes, sir.
Thank you.
Mr. Meny.
Thank you, Ranking Chair.
I don't think your mic is on. There we go.
Oh, thank you, Ranking Chair. The life cycle cost estimates for any program are extremely important, as you know. And as I said earlier, the understanding of user observation requirements and what those requirements are is very important as well. That derives what will be allocated to a satellite program or another platform of how you get that data. So understanding that baseline is extremely important. GOES are, as you brought up earlier, initially in its development, there was a hyperspectral sounder on it, hyper-environmental spectrum sounder on that satellite. However, it was not technology ready to be flown, and it was dropped from that program. GeoXO is going to be bringing a similar approach involved here for the extended orbits. So it's extremely critical to understand what that actual baseline will look like and how those development costs and technology readiness associated with the capabilities it's going to deliver is laid out. It's also important to test assumptions. We had reports on JPSS where we hit them up early with recommendations on looking at GAO's life cycle cost estimates and changing assumptions. So following that guidance is extremely important.
Thank you. Mr. Gagosian.
Yes, thank you. If I may, I'd also like to echo what Dr. Volz said about having a variety of different cost models that are run early in a program. They all have different assumptions and techniques that are used, and so by having a suite of different models, we're able to let's say, determine a cost target early on that has some realism to it. But really, I want to fall back on the NASA process, which is not to validate the cost estimate and really commit to the cost until what we call key decision point C, which is after the preliminary design review occurs on the system. So we have a standing review board fully review the design. They look at all the risks. They do what's called a JCL analysis, a joint confidence level analysis. And by the time we get to that key decision point, we have been able to shake the design out and come up with a much more confident number as to what the cost will be.
Thank you very much. And Mr. Chairman, my time has expired, even though I have several other questions. Okay.
Mr. Ranking Member, if it's okay with you, I hope we'll do a second round. Okay, good. In the meantime, let me recognize the distinguished gentle lady from Oregon, Ms. Bonamici.
Thank you very much to the chairs and ranking members and to the witnesses. In Northwest Oregon, where I'm honored to represent the 1st District, we are experiencing the effects of severe weather patterns that cause more intense heat waves, actually, and longer fire seasons. And just this month, the combination of high winds, extraordinarily low humidity, fueled wildfires in Oregon that caused evacuations of some communities, and also 2 of our regional power utilities conducted planned shutoffs that affected more than 40,000 Oregonians. So as we invest in climate adaptation strategies to reduce the consequences of extreme weather, the need for accurate and timely and consistent data is essential, especially for resiliency efforts in those vulnerable communities. So, Dr. Volz, in the Pacific Northwest, we rely on quality data about the ocean to support industries like our fisheries, protect marine life, to build resilient communities. So in addition to operating the nation's weather satellites, as you know, the National Environmental Satellite Data and Information Service, NESDIS, is home to the National Centers for Environmental Information, NCEI, which serves as a repository for many of the domestic and international sources of environmental and climate data, and information services to inform climate change mitigation and adaptation. So Dr. Volz, how does NESDIS, through its weather satellites and CEI, how does NESDIS support the broader landscape of NOAA's climate change mitigation and adaptation efforts? And how can next generation weather satellites integrate with ocean monitoring systems?
So thank you, Ms. Bonamici, for the excellent question. And the other piece that we often forget when we talk about NESDIS is the information service, as you mentioned, the National Centers for Environmental Information. So the primary function of the NCEI is the archiving and retention of all of the global climate environmental observations that we make. And it's just the archiving and storage, but it's the utilization of those data which are so key. The ocean observation systems, the ocean observation data that we have and collect are part of NCEIs. And these are, through our partnerships with the National Ocean Service and the National Marine Fisheries Service, are key information parameters for those services to determine the changes in migration, fish migration species, the changes in the ocean, the dynamics in the ocean environment. So we work closely with them for the archiving of their data and the integration of their data with other data sets that we get from other sources, as well as satellites and other partners. So the looking forward, as you mentioned, the changes that we're seeing in the environment, whether it's ocean heat waves, heat events, such as the hot blooms that have occurred, are a key part of our forecasting requirements, that we understand those better and forecast those better because of their impacts on the fisheries and the economies of the.
We had a hearing yesterday on the Arctic, and we heard that they're having trouble with harmful algal blooms up there, sometimes for the first time. I want to follow up. Earlier this month, as you know, NOAA and Department of Interior launched a portal for climate mapping, resilience, and adaptation. So how is this data distributed? How would a more cohesive climate service benefit the mission of NESDIS? We heard in the testimony earlier that NOAA needs to better align data with the needs of users. Is that something you're working on?
It is, and it is an important piece. It's not just having the data, but it's getting it to the user. So we have had a number of interactive sessions with communities around the nation and in the regions to try and understand the data use needs that they have at the NOAA level, the NESDIS level through our regional climate service directors and our regional service divisions. We're working directly with state and local users of our data to provide and improve the delivery of our services. It is a scaling challenge for us as we are changing the way that we deliver data to our users. And one of the initiatives we've started is to move all of our data into a cloud-based format, our NESDIS Common Cloud Framework, which allows for much easier, more rapid dissemination of data to different users. That just opens the portal. It doesn't tailor the data to the users as well as we need to. And that's part of our ongoing activity, is through user engagement to define the best way to provide the data to those multiple users through our regional and local interactions with the communities.
And what's causing the scaling challenge? Is it funding? Is it workforce? Is it technology? Why is
the technology? It's the application of technology, number one, because we do have the ability to use the cloud in a way to disseminate the data better. But there's also it's a need for better and more engagement with the communities, and through workforce growth in the RISA, which is the science organizations out of OAR, Office of Atmospheric Research, and our climate service directors, is actually engaging and setting up a larger framework of dynamic interactions with the local communities in order to tailor those climate products, which are different from the WFO, the weather products, as we see that as definitely the growth area over the coming years as part of a climate service that we will be setting up and establishing and delivering.
Thank you so much. I see my time has expired. I think I heard from down at this end of the dais that there may be another round, which is a good thing because I have more questions. Thank you. I yield back.
Great, excellent. I figured you would. Let me now recognize the Congresswoman from Oklahoma, Ms. Bice.
Thank you, Mr. Chairman. Dr. Volz, as I mentioned in my opening statement, data processing, distribution, and assimilation are critical and often overlooked part of satellite operations. I think a low-hanging fruit to increasing access is transitioning to capabilities to the cloud. I know this has been an emphasis at NOAA for a couple of years, but I'm concerned that that NOAA tends to prefer owning and managing their own hardware internally when running things, rather than running things through a commercial cloud software provider, which is oftentimes a cheaper and more efficient solution and comes with less headaches. Can you tell me more about NOAA's current cloud capabilities related to satellite data and your outlook on the future of cloud services with next-gen satellites?
Thank you, ma'am, for the question. And yes, I'm happy to. It is not an either or. It's not we do it in-house or we use the cloud. It's going to be a combination of both. And what we have specifically done within NESDIS is to engage with the cloud service providers, several of them, in order to move our data to a cloud environment for easier access and dissemination. Now, that doesn't solve the usability problem, because you have to understand how to use the data as well as how to get it. But it is a way that we are moving the accessibility to our cloud, to our satellite data directly to a cloud-based environment. Now, across NOAA, there are a number of different activities happening with there's the NOD, which the NOAA Open Data Distribution Network that NOAA is trying to do writ large. I think there is a general understanding within NOAA the need to move dissemination or accessibility to our global data sets to a cloud environment, while still having a large portion of in-house processing and capabilities that are necessary for the dedicated weather forecast modeling and forecast development. So it's a combination of both, and it is a big part of our FY20, our budget initiatives, asking for access to funds to develop a more rapid dissemination and migration to cloud environment within Nestus.
Thank you for that. And to follow up, in a previous hearing, there was a conversation around collaboration with NOAA and DOE. DOE has some of the most powerful supercomputing capabilities of any agency in government. And so can you talk a little bit about what type of relationship and how that's going?
So not in great detail, but I'm happy to take that question for the record. I will note that even as we move more data to the cloud for dissemination, the need, as we have more complex data and better models of ecosystems in the larger environment, we'll need increased access to high performance computing to demonstrate the models which are more complex, taking in these new data sets. So our NOAA is working with DOE, and I'll be happy to take that for the record to get some comments back to you on the progress of those coordinations with the DOE.
I would appreciate that. I think that with DOE's capabilities, supercomputing capabilities, there is an opportunity for collaboration rather than sort of reinventing the wheel and spending additional resources that may be able to be utilized for other technologies, including new satellites. So I thank you for that question, and we'll submit that for the record. To follow on that, the National Weather Center in Norman is home to both the Advanced Radar Research Center and the National Severe Storms Laboratory. Additionally, the NextRad Radar Operations Center is a frequent collaborator just down the road. And while today's hearing is certainly focused on weather satellites, we can't forget that the next gen of ground-based radars are also being developed. Dr. Volz or Mr. Gagosian, with the understanding that satellites take years to develop, build, and launch, as well as the fact they can't be moved from orbit for upgrades, how does NASA and NOAA ensure that space-based instruments complement ground radar and account for potential improvements to terrestrial observations?
So let me take that first, John, and then I'll turn it to you for addition. So within NOAA, we have the NOAA Observing Systems Council, whose primary focus, and I'm one of the co-chairs, along with the National Weather Service Director and the Office of Marine and Aviation, our co-chairs. We look at the whole system of observations that NOAA has, including ground, space, ocean, et cetera. And the complementarity of the ground-based radars with the space-based assets are understood and reviewed as a part of the general investment strategies we have. And I'll note, for an example, they actually back each other up. If you go back to the incident with Hurricane Maria over Puerto Rico several years ago, the one National Weather Service radar system was knocked out by the hurricane. And during that period of time, before we get a temporary replacement in place, we used proxy satellite data as an equivalent radar system to provide the wind, the radar forecasting, the weather forecasting for the island until we could have a ground-based system assessed. So they do complement each other, even though they are different. But we are focused on the delivery of service and not on the continuity only of a particular technology asset. And John, I don't know if you had anything you wanted to add to that.
So my organization is not really involved in development of the ground-based radars, but one thing we are doing, we're working with NOAA on, is reducing the development timeline for new space systems. So a quick sounder is really a pathfinder for that. We're trying to close the gap that way.
Perfect. Thank you, Mr. Chairman. I yield back.
Thank you, Congresswoman, very much. Now let me introduce the Congress's greatest champion for travel to Mars, Mr. Perlmutter from Colorado.
I was just coming in to kind of settle in and listen, Mr. Chairman, but if I'm happy to pass and come back to me, or I can fake it. What would you like me to do?
If you would prefer that we come back to you
Please.
After Mr. Feenstra, we'd be happy to do that.
Sure.
So then
Now we'll see if he's ready.
He's been here for a while. Mr. Feenstra from Iowa. The floor is yours, sir.
Well, I'd just like to say thank you to Chairwoman Sherrill and Chairman Byer and Ranking Member Bice and Babin for holding this hearing today. And I really want to thank the witnesses for their participation. The collaboration between NOAA and NASA on weather satellites is vital for my district. It's important that we understand what's happening at a very quick time. I have seen this time and time again. In December, we had significant storms move through Iowa. 2 years ago, we had the derecho that was unheard of at the time. And there's still a lot of concerns. I was excited to tour the National Weather Service Forecast Office on my August recess. And I started understanding the importance of weather radar, both ground and satellite. And that is my question here is, as we move forward, it seemed when I was at the National Weather Service that they were having a difficult time disseminating tornadoes that were F0, F1s, and it was pretty late that you could start seeing F2s and so forth. But it just seemed what was happening was they could see it at 8,000 feet and higher, but at lower levels they could not. So my question to Dr. Volz would be, is there a way that we can start using satellite radar and satellites to disseminate some of these lower ground tornadoes that start at zero or start at F0 or F1s that turn out to be F3 or 4s? Do you see any research going down that path when it comes to satellites?
So that's a great question, sir, and I appreciate asking and knowing how sensitive that region of the country is in hurricanes, to tornadoes as they occur. And you've identified one of the key challenges we have from observations in near real time, which has to be geostationary, is really looking down through the atmosphere and getting to the lower levels of the atmosphere. And that is probably one of the primary benefits we're going to see from our from the geostational hyperspectral infrared sounder. The imagery we have right now can be blocked by clouds and has limitations in the vertical accuracy or resolution of events. Whereas the hyperspectral sounder will allow us to be much more accurate in measuring the wind speeds and direction at multiple levels of the atmosphere. Exactly the phenomenon you were identifying in your trip for the WFO. So the research is going on based on airborne research and other research on how to model these events and how to see them from space. Our sounder that will be launched as part of GeoXO will be our improvement in the technology, but we're working with our partners in Europe who are flying a similar sounder in a couple of years and hoping to be able and benefiting from their experience so that we can develop products and use them soon and right away when we have our systems on orbit. So it is a key piece of what we can do with the next generation GeoXO, and is an example of what we acknowledge, what we don't know now that we now know how to understand better. And that's why we're putting these into our program.
Thank you for those comments. That's very important. I'm glad to hear that as we move forward. I mean, technology is so critical, and so is research. Dr. Volz, on that same vein, obviously, in Iowa, agriculture is paramount. It's probably our most important economic engine that we have. And that being said, we have a lot of agricultural producers that go down this path. It also includes precision ag. And do you see any collaboration when you look at precision ag and new weather satellites that could work together in some capability to help agriculture? Is that anything in that area on the radar?
Yes, and I think that's a key piece, sir, of our mission objective. Is not just to tell you when it's going to rain or not rain, but also to give you a time-based understanding of the environment you're dealing with. In our research into seasonal and sub-seasonal forecasting, that would be of value to agriculture in the broad base, but also locally, about the precipitation outlooks looking beyond the next week or 10 days to the season. So you have an idea of it will be wetter or drier, which can impact the choice of your seed crops. What you're going to put in the year, what particular type of seeds that you want to plant. But from an ecosystem point of view as well, what are the forecasts in the near term for humidity and soil moisture over the coming weeks, so that you can, again, decide to tailor the application of fertilizer or of irrigation to maximize the effects of the performance of your crops. So these are tailored, better information products that are possible with better integration of the observations and the modeling that are taking place within ocean and atmospheric research right now, but also through better data sets that we use. And NASA doing some of their research product development as well, understanding ecosystem health as a part of and using satellite data for that. So I think we definitely have a strong customer in the agriculture community, and not at the regional level, but at the almost at the crop and field level. We can provide these kind of tailored and specific information.
Yeah. Well, Dr. Volz, so thank you for that information. Hopefully we can continue to work collaboratively on that. And with that, I yield back.
Thank you, Mr. Feenstra, very much. If the head coach of the congressional softball team is prepared,
I'm readier, let's put it that way.
recognize the gentleman from Colorado.
Yeah, I was down, we're asking questions of the CEOs of the biggest banks downstairs in financial services. So, but I said, no, I got some scientists I got to go talk to. So I guess my first question, I know Ms. Bonamici was asking in this area, and I'm sorry if I repeat her question, but just, you know, obviously wildfires have been a huge stressor in Colorado and the West. And I just curious what you all at NOAA and those at NASA, what roles you're playing to assist our wildfire fighting efforts. So I'll start with NOAA if you like.
Sure. Thank you, Representative Perlmutter, and thanks for the question. Yeah, the wildfires are right on everybody's front page. And I would say that one thing we've learned from GOES-R series of satellites, we've revolutionized the way that we address and serve the fire mission from space. Often the first call that a constituent might get that there's a fire in their neighborhood comes from the NOAA Weather Forecast Office because they have the image directly from GOES-R. So we recognize the value of early and accurate detection and pinpointing of locations of fires, which come from our geostationary satellites. And we realized that and our next generation, so we're continuing working that with the fire managers on providing that information in the most effective and efficient way. Our next generation has been tailored to improve that with higher spatial resolution and better choice of bandwidth of frequency so that we can see the initiation of fire more accurately and precision. And we've realized that the return on value on investment of that is significant. The sooner you get to a fire, the sooner you better chance you have to contain it and to reduce the impact of large fires. So part of it is is better observations. The other part is getting that information directly to the users in the right way. We've had a number of workshops with state and local fire emergency managers to get the information. They don't need a GOES image, they need a pinpoint location to tailor the information products in real time so that they can accurately work with them and address it quickly.
So are you all part of the firefighting team? I mean, do you have somebody stationed up in Boise? You know, do you have somebody out of your Colorado offices that's dedicated to that?
We work with, our weather forecast offices are now actively participants with every region around the country in dealing with the fire seasons when they occur. But for example, with CAL FIRE, we work with FEMA, but also through our weather forecast offices during emergency management of fire events and during fire seasons. So yes, it is distributed. The information is sent directly to all of our WFOs. And we work directly with the emergency managers in the different regions on responding to fires and anticipation of those.
Okay, does NASA play any role in this, in the firefighting efforts?
So what Dr. Volz is describing is the operational role of NOAA. NASA is more oriented around the research side, understanding the dynamics, the conditions. And if you want, I can take a question for the record to tell you what kinds of space-based and/or air-based assets we're using for that.
I'd appreciate it, because what we found in Colorado, California and Colorado, I think Oregon too, is also using sort of Defense Department assets through Fire Guard or something like that to help us, as quickly as possible pinpoint these things, then take the data developed by NOAA and the Weather Service to figure out where it's going to go and how quickly it's going to get there and how to maintain it. So I would appreciate that. I guess, Dr. Volz, I have another question, probably out of left field. The Office of Space Commerce. How is it, and for anybody who want to talk about it, is it folding into NOAA and the Commerce Department well? How is that working? Because we're kind of moving some responsibilities out of NOAA directly into that Office of Space Commerce?
So the Office of Space Commerce is not moving out of NOAA. It's moving from NESDIS to NOAA, both still within NOAA, but to directly reporting to the Undersecretary of Commerce, Dr.
That's what I
Spinrad.
meant. Thank you.
Right. So that transition is still in work and it's moving along well. Richard Dalbello, who is the director of OSC, is actually here with me this week at the International Astronautical Congress, working with a lot of the international and technology partners on space commerce and space situational awareness. So that is an ongoing activity that is moving along well. And it may be a little bit out of left field, but it's still, if you wanted to start talking about space weather, we're a key part of compatriots in understanding the near Earth environment of the low Earth orbit, where space commerce and space situational awareness is going to be a key activity.
All right, thank you very much. I'll go down and talk to those CEOs now.
Thank you, Mr. Perlmutter. Now let me recognize the gentleman from Cape Canaveral, Congressman Posey.
Thank you, Chairman Byer, for holding this hearing on the next generation of weather satellites. Dr. Volz, currently there is no geostationary orbit sounding capability over the United States. With all the recent flooding, what are we doing to accelerate and prioritize the development of that critical technology?
So thank you, sir, for the question. And the hyperspectral infrared sounder, which is a key component of the GeoXO program. As Fred Meny mentioned earlier on, it had been conceived of for the earlier GOES-R, but was deemed not sufficiently ready for the implementation in 2004. It is now, and we have actually had study contracts with vendors to build this into our program. And we fully expect and hope it will be a part of our located centrally over the U.S. in our GeoXO constellation, providing hyperspectral infrared sounding over the U.S. We are working with our European partners. We'll be flying a similar instrument in about 2 years to understand the application of that instrumentation for weather forecasting and all the other applications we might see. So we're looking forward to having that available for you and for all of our customers here to better understand storms and weather across the U.S.
I'm certainly glad to hear that. And as a follow-up to the first question, specifically, how do you protect American innovation and ensure that the American geostationary orbit sounding technology will remain on the weather satellites of our international partners, such as Japan and South Korea, enabling the full sharing of this data?
That's a great question. And we have benefited, as you're implying, over the last 30 years that Japan and our Korean colleagues have used U.S. vendors and U.S. instruments to fly the imagers, for example, that are flying right now. And that common instrumentation is a great space and time saver, because we have the same observations from Western Africa to Central Asia, from the same instruments and the same measurements, and it helps our U.S. industry as well. We have been working closely with our partners, Japan Med Agency and Korean Med Agency, to encourage them to follow, and they have followed our lead in the past. The sooner we get our systems designed and defined and initiated, the greater the likelihood we'll be able to maintain and continue that coordinated development with our Asian partners who have been key participants with us over the past. They have their own timelines, and they're eager to get going on geostationary observations for this next generation as well. So it's a race to get the start going as soon as we can, and we hope to see GeoXO confirmed within our own department in December of this year with the path forward defined.
Well, that's great. You know, other agencies are rapidly increasing their low Earth orbit satellites to advance capabilities and achieve more frequent global refresh. You know, what is NOAA's plan for moving out on the next generation of low Earth orbit?
I'll start and John can finish. We are already in a rapid acceleration of low Earth orbit assets. And one of the key hallmarks of NOAA's program is that it's not just NOAA satellites we use, it's everybody's if they have good data that we can use. And we now incorporate data from 20 or so different agencies and national partners into our numerical weather forecasting based on interagency partner agreements. So we already are disaggregated. NOAA is working with its quick sounder approach to complement the JPSS program with a upcoming series of small satellites focused on individual observations. And that's part of what John Gagosian was saying about the innovation is not just in technology, but it's in the implementation approach, which allows for a rapid refresh, new technology infusion, and integration into our programs, and utilization of commercial assets when they're available. And that's a key part of our overall program.
Do you think it's possible to accelerate launches, move it up even faster?
Yes, it could. It is, sir. I think the quick sounder approach that we've initiated just this year is targeting a 2025 launch. And with with the appropriate funding and the positive outcome of this program, we are looking at the second half of this decade. We could be launching the next generation of complementary missions from small sats out of the NOAA program.
Well, that's really great. And I see my time's about to expire, so I yield back, Mr. Chairman. Thank you.
Thank you, Congressman Posey. I will now do a second round of questions for the stalwarts who are hanging in. Let me begin. Mr. Meny, we just heard a lot about, the next generation of satellites and GOES-R, GeoXO. One of your recommendations was that the next generation satellite programs don't define more stringent requirement thresholds than the corresponding thresholds in the data set. Tell us more about that. Is there the notion that we're over-designing based on what we can actually use?
Thank you for the question, Chairman. The situation is that NOAA's policy on their user observation requirements is to look and revalidate those observation requirements at least every 4 years. In our work, we found that 76% of those observational requirements haven't been revalidated over 5 years, and 18% haven't been revalidated over 18 years. So when you look at that process, it's hard for the user observation requirement to transcend down into what is being built on a satellite. So typically, the satellite programs are putting together their specifications, and their thresholds, which is what the minimum requirement is much higher than what is in the user observation database. So what we're saying in that case is, one, the policy for looking at those requirements should be refreshed and updated to be more accurate if that's the need. And then two, if in fact the threshold requirement, the minimum requirement is what is acceptable, maybe that should be an an objective requirement and have a lower trade-off. A smaller requirement underneath that, so there's a trade space. We found that in the GOES magnetometer recently, the one that was had a problem in development, its actual mission was meeting much higher. It was supposed to meet much higher requirements than what was actually in the prior series, which they fell back to do. And that's in the GOES-R program, the only requirement that has a difference between the threshold and objective values.
Great. Thank you very much. Dr. Volz, I'd love you to respond to it, but let me also throw a question on top of that, which is, you had said that 90% of all data used by NOAA's operational forecast is coming from satellites right now. I'd love to know about the relevance of the extensive network of ground-based weather observation right now. How relevant is that last 10%?
Absolutely essential, sir. So the 90%, 10% is not a valuation of 90% value, 10% value. Without the ground data sets, the satellite data sets would be unmoored, unconnected to ground calibration and validation. So it is essential that we have both. But what the satellites provide is that global picture, especially over the oceans and in sparsely with places where we don't have ground calibration and validation, to give you that global picture, which is essential for doing the long-term forecast. But the ground data sets, the ASOS networks, the weather service, the balloons, the airborne, are absolutely necessary to have a well-performing system. But we need both, in other words. Back to Mr. Meny's point, I fully agree that our requirements validation process that identifies a certain refresh rate is not being satisfied. We did not meet that. However, we did not rely on archaic requirement sets as the basis for definition of the GeoXO. Recognizing this was a problem, we actually went out and extensively researched and communicated with the end users and the internal NOAA users on how they want to and expect to use observations from geostationary, and built that into our requirements definition process. Recognizing that we don't have the refresh rates that we need, but we are working in parallel to improve that. Through as we go to each program, we're looking to upgrade and update the requirements data sets. But I fully agree with his point that we need to accelerate the refresh approach that we have for our requirements. And that's one of the objectives, again, through our NOAA Observing Systems Council, that we are we're championing within NOAA to make sure that we do this more systematically. But rather than do everything at once, we're focused on the ones where we have to make investments and making sure those investments are based on well-validated requirements, which we do believe we have for GeoXO.
Great, thank you. Mr. Gagosian, do you have any short follow-up to that?
Very short. I just wanted to point out that for all of our design reviews for GeoXO, all of our life cycle reviews, we have now specific criteria for user engagement to make sure that the kind of user engagement that Mr. Meny was describing is actually occurring.
Great, great. Thank you very much. Let me recognize the ranking member of the committee.
Yeah, thank you. I'm glad to come back through with the second round. I appreciate it. I have an additional question for Dr. Volz and for Mr. Meny, NOAA and the Inspector General's office. Will the Department of Defense's future weather plans include flying the Visible Infrared Imaging Radiometer Suite, or VIIRS, instrument? VIIRS was the source of a lot of problems during the development, and the taxpayers invested a lot of money to ensure that it met both NOAA and DoD requirements. Despite early issues, it has returned tremendous scientific and operational results. NOAA flies VIIRS on JPSS right now to the benefit of DoD. And it is my understanding that DoD recently decided not to fly VIIRS in the early morning orbit, which it is responsible for after the breakup of NPOS. DoD has a much larger budget than NOAA. That's an understatement. So it's a little odd that NOAA may be carrying DoD's water in this instance. Furthermore, I wonder if there would be any discrepancies with data continuity if DoD was to fly a different sensor, or a gap in coverage if they don't fly any sensor at all. Can each of you elaborate on the benefits of the DoD flying VIIRS?
Thank you,
Volz?
sir.
Yes, sir. You first.
Question. So yes, the VIIRS was a beast to build. It was, as you mentioned, I think MODIS was the precursor, and we ended up building VIIRS. It is a very capable instrument with multiple, and it's turned out to be the greatest producer of products that NOAA, that the JPSS program produces. Many, many applications have been benefited from that, and we will be flying VIIRS through the 2040s on JPSS 1, 2, 3, and 4. The DoD's need for imagery in the morning orbit does not require the full breadth of what VIIRS provides. It requires a fairly narrow slice of that. There was larger objectives for VIIRS. So the fact that the DoD is not flying a VIIRS in the morning orbit is certainly still meets their, as far as I understand it, and we need to have the DoD confirm this, meets their mission objectives without covering the full spectrum of what the VIIRS does provide. So we need VIIRS for what it does for us in the afternoon orbit. In fact, the Europeans are flying a similar instrument called NetImage, which will be flying on their second generation in the morning orbit. So between EUMETSAT and NOAA, we will have two orbital coverages, not exactly the same instrument, but close. And the DoD is going with a different approach for their specific mission objective, which really was one of the reasons for the failure of NPOS, was that the divergence of requirements led to different missions and different observations in different orbits. I don't think we're carrying the water for the DoD. I think VIIRS is a service suite that services us, but many others. And we hope to benefit from their observations in their orbits as well when they are flying their disaggregated imagery in the coming years.
Okay, thank you. Mr. Meny.
Thank you for the question. Unfortunately, we haven't looked at that, so I'll have to take that for the record to come back. However, I do understand the concern about what we're doing for other services when they have a larger budget than what Commerce has. So
Right.
we'll take a look at it, but for their orbit and picking up VIIRS, I don't have any information I can provide right now, but I'd be happy to take your question for the record.
Okay, that's good. I think I'll just yield back to you, Mr. Chairman. Thank you. Thank you all.
Thank you, Dr. Babin, very much.
Sure.
I recognize the Congresswoman from Oregon, Ms. Bonavici.
Thank you, Mr. Chairman. There have been a couple of hearings in this committee that the reaction was, this is incredibly alarming, and one of them was yesterday about the Arctic and the melting permafrost, and the other one was about spectrum, so that's what I'm going to ask about. This committee's had a long history of bipartisan concern about harmful interference in the radio spectrum that can undermine the performance of scientific instruments such as NOAA weather satellites. Last summer, this committee held a hearing to examine the potential radio frequency interference that could possibly deteriorate weather forecasting capabilities, as well as opportunities to mitigate any harmful interference. So Dr. Volz, why can interference be so harmful and challenging to mitigate for the types of measurements that NOAA satellites collect, especially for passive remote sensing? And what are your concerns for future radio frequency interference with the Earth remote sensing satellite operations, including any actions or developments at the domestic or international level?
So thank you, Congressman Bonamici, for the question related to the spectrum. The reason that the active use of the spectrum from terrestrial sources is a problem for us in some areas is that we rely on, with our passive instruments, microwave in particular, looking for the passive emission of signals from natural sources in various bands through what are called transparent or atmospheric windows, things that are not attenuated by the atmosphere. And a couple of those, they happen to be those places where the atmosphere doesn't attenuate radio frequencies are the best places for radio frequency uses as well. So there's a conflict already between the passive window and the active use of that. And we saw this in a couple of the microwave soundings, like at 24 gigahertz and in the 50 gigahertz range, where those are windows that we use because they reveal temperature and pressure profiles in the atmosphere all the way down to the ground. And now those are where you might see 5G applications. You sell that spectrum for other use. So what the problem is, if there's an active source, it interferes with the passive, and the active source can be much larger and time varying, and it raises the noise level of our signals and eliminates the value of the observation. So that is a concern for us, for all of the observers of the passive observations of the planet, of the Earth. And it is, and there have been a lot of ongoing activity on how to co-use and the band, how to coincident or reside in the same spectrum and nearby. And I think that is, we have ongoing conversations with the World Radio Conference, the WARC as we call it, to try and find the right separations between active use and passive use. And I think we have a better place now in the coordination and discussion on what are the allowable uses in parallel bands, but it requires a careful coordination going into the global application.
Well, I'm going to ask Mr. Gagosian then, how does NASA incorporate radio frequency interference mitigation technologies into the development of weather satellites?
So when you're looking at how to mitigate, we are working with NOAA on some studies for instruments that we could fly to measure the ground-based interference sources. So we've come up with concepts, and at this point, really, it's a trade-off, right? There's a certain investment that would be required versus the potential impact on the observations, and Dr. Volz can confirm this, but I think it's up to NOAA to really do that trade, right? To assess the cost versus the benefit of that type of instrument. But we have collaborated with them on those studies.
Terrific, thank you. I yield back. Thank you, Mr. Chairman.
Thank you, Congresswoman. Now, finally, recognize the Congresswoman from Oklahoma, Ms. Bice.
Thank you, Mr. Chairman. I actually don't have any additional questions, so.
All right, well, thank you. Then I believe we are done. Good. Well, before we bring the hearing to a close, thank you very much for hanging in through these long 90 minutes. For all our witnesses, for being here in person and virtually. And thank you for the work you do. The weather, whether you live in Oklahoma or Oregon or even Virginia and Texas, it's incredibly important. And knowing and being able to predict what's going to happen today, tomorrow, and next week is essential. So thank you very much for all that you do. The record will remain open for 2 weeks for additional statements from the members or for any additional questions the committee may ask of the witnesses. The witnesses are excused, and the hearing is now adjourned. Mr. Chairman, excellent. Thank you, Ryan. Good to see you. Thank you very much. Thanks, Stephanie. Okay, perfect.